So hello, much. Hello everyone. We will start. We will start the second session of CCAMP in this Sense meeting. So we covered yesterday all the admin slides. We will just go today through the admin one. Oh, just 1 second. I need to. Okay, we will go just to the node well. So basically to remind the participants here the correct behavior in the participation, the professional behavior with the rest of participants, and basically that all of you should be aware of the IPR things that rights that apply to the whatever content that you can present here or you want to comment. So being said that, on further comment is a change on the agenda. Yesterday we could not cover Nigel's slides. We will cover as the first slot today. And yesterday we covered the ones from Scott, so the last item in the agenda is removed for the session of today. So with this, if there is no any agenda bashing, we can move forward. Okay. So Nigel, do you want to have the control of the slides?
Yeah, if you don't mind, I should be able to do that, yeah.
Okay, in just 1 second.
Thank you.
We will share the slides and give you the control.
Thank you. Okay, thank you. So first of all of my camera says it's on. It won't let me share, so I can't. You can't see me, but hello, I'm here. And thanks to the chairs and to Scott, of course, for rearranging the session, and apologies for not being able to manage my calendar properly. I'm presenting data modeling and gap analysis of optical pluggables and packet over optical networks on behalf of the team there. Reza can't present today because he's buried elsewhere, so I'm presenting on behalf of him. Let's see if that's all good. So it says progress since IETF 123, so I can't subtract either. It's 124, obviously. Since then, we've had working group adoption. So there's the draft. I put the links in here. Works on GitHub. We've had ongoing calls for a while, obviously, as you know, as we presented last time. We're continuing to do that. Our work's been done primarily initially around the Google Sheet. We continue with that sheet as a detailed view of the pluggable attributes that we went through a long time identifying all possible attributes that we could see on the optical side. I'll speak on that very briefly later. We've looked at the capability attributes. I think we've gone through those. Essentially, they're complete. There's a couple that maybe we need to refine a bit further. That's the description of things that attributes that describe things that the plug can do. And then we've got a few configuration attributes and a lot of PM and state attributes, which we're working through at the moment to close any remaining issues. That list has a number of gaps again in it, so we're finding things that we need to add. I'll explain to what in a moment. The gap analysis document itself, or section itself, is being updated and refined. I realized I can't see the timer anywhere. I don't know why I can't. I suddenly thought, hold on. Okay, I'll keep an eye. Give me a minute. Give me a warning when I've got to a minute, and I'll if I get that far, and I'll then stop. But we're on a sort of a second pass of that. The key thing here in the gap analysis now is to provide guidance on how to address the gaps. If I move on, does it let me move on? No, apparently not. Click. Oh, nothing's letting me move on anymore. Oh yeah, there we go. Good. There's a big delay, I think. Hopefully I didn't go on too many slides. Just make sure I haven't gone too far here. What's the next slide? 1 second, sorry. Yeah, okay, good. So the goal is to reuse existing IETF Yang models. We're not intending to develop new models unless we absolutely have to. So we're identifying gaps in those existing models. And the group's work is to complement those existing drafts and work. And as I said, it says in that second sub-bullet, if we do agree that there are no existing models for something, we will start new work. We're not seeing any reason to start new at this point, although when I talk a bit later about other aspects of the plug, we may find things we need to do in those areas. The gaps have been agreed, and we're adding attributes as appropriate. A key observation is that the work's focused on the line side, so the photonics, and the properties we've discussed really are generally applicable to photonics. So although we're under the heading of pluggables here, we're looking at the optics of the plug primarily, and of course that the optics. So on that basis, this has sort of helped us add to or keep that aim of adding to existing work. Let's see if this will move on or not. I've clicked it. It's not doing anything for me. It's just very slow. Okay. So this the structure of the draft. The main goal of this is the gap against that list. As I said earlier, capability configuration state. That list. There are very few config properties. There's some guidance on how to fill the gaps, and we're relating to the work that the operators have been doing in their use case document, which Oscar has been leading. And if we find other stuff which would be beyond work, so if we're looking at other areas perhaps, then we might need to broaden the activity, look at the use case document to drive that to make sure we're not going well beyond what we should be doing. We then introduce new subsections in the document to cover those new areas. Obviously, look at examples of areas, for example, in services and so on, which we're not expecting to have to get into, but could be in that area. We'll create subsections in the draft to cover those, and if we do need to do this, we'll have to assign people and so on. So we probably more extensive. And we're going to go to try and scroll on. Yes, good. So ongoing work in this document, this area, we're refining the gaps, looking at the parallel Google Sheet, developing Yang models, as we said, and looking at other aspects of pluggables. This is what we're going to. This is what I want to expand on a little bit. So our focus has been on the optics. There are other challenges in the pluggables that we need to look at. One is the backside of the plug, so the bus from the plug to the host. We haven't looked at that in detail. Traditionally, in our work here and in other bodies, we wouldn't tend to model that sort of thing because this is internal detail. So if you look at the way we traditionally model devices, you model what you can see from the outside. So the bus is the lanes are very much like backplane, essentially. So you wouldn't normally touch that, but here there's a vendor boundary, so that might be something we need to look at. So it's an inter-vendor interoperability boundary. The second thing is again on the multi-vendor aspect is dealing with the properties as maybe the plug definitions in the CMIS, or available information from the plug in the CMIS, OIF CMIS work. As that expands, they may add new properties, add new capabilities, and so on. And that might be happening to a plug in the network where the host has not been updated to cover that. And the question is, how do we deal with that situation? There's another group that's working in conjunction with people from IETF and TIP and OIF, Telecoms Infra Projects, or OIF, the Optical into Working Forum, I think, to look at how that might be handled and how that challenge might be handled, and also the proprietary properties on the plug would be potentially difficult to get out of the plug. So that those are areas we might need to work on as we move forward. As I said, another group is covering that in some detail. And then also that it sort of works on where the capabilities might be needed. So obviously the plug can express capabilities, but in addition to that, when you're planning to incorporate a plug, if it's not a basic ZR or ZR plus plug, if it's got some special properties in it, then you'll be planning those ahead of time, and therefore the capabilities simply arriving from the plug aren't necessarily sufficient. So aren't sufficient because you haven't put the plug in yet. So you need to understand how to get those capabilities and make those available. So those are areas we might want to look at in the next steps. And as we said, if there's other stuff beyond that, those are still within the scope of the group because obviously they're related to pluggables. But if we're beyond that, then we need to pull in other stuff, broaden the mandate, and so on potentially. So I think that's essentially all I wanted to present. Again, thank you for letting me present today rather than yesterday. So, any questions?
Any question? Nigel, thanks a lot.
Thank you. Is that a question? Or? It is.
Hi.
Hello.
Rod Van Meter. So I did just stick my name in the queue there. It took me a minute to find it. Sorry, I'm not a normal participant in this group, so I'm pretty far out of the loop on this. But the Google Sheet is there any reason that that's not globally readable? How do we get access?
Oh, that's interesting. There's a link in here. Have you tried the link actually? Try the link.
I tried the link from the slides, and the link from slides tried to put me into editor mode, and
oh, maybe I put the wrong. I may have put the wrong link in the slide. Sorry. I grabbed that the other day. I could. You should have access to read it, I believe, so we can make that available. It's not supposed to be private, so we're not trying to hide. So maybe
Thanks. I'd like to take a look at it.
Yeah, of course. Yes, of course. Thank you.
Okay, this is Xin Zhao from CAICT, and this is a new work, and today I will present the new work on behalf of all the authors. And the title is The Integration of Network Management Agents into ACTM-based Optical Network. So firstly, we can have a quick background. And we proposed the AI-based network management agent draft in 2024, and the latest version is 04. And now we are trying to ask for adoption of the working group. And here, NMA equals the AI agents for network management, and is a new network management entity which have the capabilities to create autonomous closed loop. So that's the basic background. And why do we propose this draft in CCAMP? Because we believe that the existing ACTM framework lacks higher level autonomous capabilities. And we all know that AI agents are really hot and are widely accepted in the industry. And also we already have the NMA working in MOP. So maybe we thought maybe it's the right time to explore the introduction of NMA functions into ACTM-based optical networks so as we can achieve high-level autonomy. And this draft will define the NMA enhanced ACTM framework, will define new interface requirements, and will describe some typical use cases. And this draft will not define specific agent implementation details or any interface protocol or model definition. So we thought those are works need to be done in other drafts. And first, let's take a look at the NMA enhanced ACTM framework. As you can see, the NMAs are embedded as some enhanced components into each layer of controllers. So we can have the enhanced CNC, enhanced MDSC, and the enhanced PNC. And also the CMI, MPI, and the SBI need to be extended either. So here we want to make clear that the NMAs are introduced to augment the ACTM framework, but not to replace them. And we choose this integrated design to ensure backward compatibility, because we think that is really important. And as you can see, there may be multiple agents on CNC or MDSC or PNC. So we introduced the agent proxy mechanism to manage the multi-agents to multi-agents communication. So the proxy is for implementing the enhanced CMI or MPI, and it will allow NMS to register capabilities and advertise to others. And it will be a gateway for NMS to communicate with external agents. So that's why we think it's very necessary, and it can avoid the multi-agents access conflicts. So this picture gives a more detailed illustration of the deployment of an NMS in PNC. As you can see, there could be multiple NMA instances, and they can interact with the existing ACTN functional modules through standardized protocols or like MCP or something like that. They can also through the private API. So the existing ACTN functional modules will expose their capabilities as APIs, and NMS can invoke those APIs. And about the interfaces, there are 5 kinds of interfaces. The first 2 are the extended CMI and MPI. They will be enhanced from the traditional transactional interface to agent-oriented conversational agent interface. So they also need to maintain for backward compatibility and full support all the functional capabilities of the original CMI and MPI. I will talk about this in the next page. And the third is the extended SPI, is other scope of ACTN discussion. And the fourth is the interfaces between NMS and existing ACTN functional modules at each layer. Since it is an internal API, so we are not considering it. And the fourth is the interfaces between NMS within the same layers, and they are out of scope of this draft too. And this page gave a more detailed description of the intercontroller NMA interaction between MDSC and PNC. There could be 2 scenarios. The first scenario is there is no NMA deployed and a certain layer, like if MDSC has NMA but PNC no, or PNC has NMA but MDSC no. So in this scenario, the NMA can still interact with the peer controller through the original REST-conf mechanism. So we don't need to do any additional modification. And the other scenario is MDSC and the PNC, they both deploy NMAs. So in this scenario, the NMAs can communicate with each other through the A2A communication over the extended MPI. And they can also interact through the REST-conf mechanism. And in the last, we also provide 3 use cases, including the service provisioning and service assurance and fault handling. And those are 3 typical use cases of NMA in optical network. So we want to show that after the introduction of NMA, it will help the automation of task processing in optical network. Okay, let's move to the end. In the next, we will keep improving the content, and we look forward to your any comments or contributions. And we hope it can be a starting point for all the AI or agentic work in CCAMP. And that's all. Thank you. Any questions?
So actually, I see that there is a lot of stuff in this draft. Some of it is the the layers that, and some of it is, so probably the best way to progress the work is to put it together, not spread it in different documents, but to understand in the future while this work evolves, if there is anything that can be generalized and made available also to other working groups and other technologies, right? You get my point?
Yeah. Okay, thank you.
So given also the fact that the NMA framework is in NMOP, maybe there is some material that probably could better fit in that document instead of this one, but I mean, as of now, let's work on the material, let's put it together, and then we will see where to split it. Is more a future-looking type of comment, mine.
Thank you.
好面 and yeah, I do believe this is a good starting point. And to answer Daniela's point, I believe because we have a lot of optical specific parameters and to be assured or to be handled in the use cases, I believe this is where our working group will finally landing as a solution, but not in this draft. This is just starting the work.
Yes, yes. At least a portion of this work fits here. Absolutely agree. Thank you. Thanks a lot.
Okay, thank you.
And guess what? We are already late. Yes. Cats.
Hi. Good morning, everyone. I'm Minxue Wang from China Mobile. Today, I'm going to present the framework and the applicability of the computation-aware traffic steering in the optical transport networks on behalf of the authors, colleagues. So we highlight how the OTN technology is used to implement the computation-aware traffic steering, CATS, and want to extend the CATS thinking into the optical transport domain. And now multi-site compute service are now very common, and the best effort to dispatch to the nearest site is often not enough. So it brings the deterministic transport into discussion. So the pure packet-based steering may not meet the strict latency, jitter, and determinism targets. So especially in the congestion scenarios. And the use cases is some workloads both need awareness of compute state and awareness of network state. And so the user cases including the AI large model training and some AI inference jobs and high performance computing workloads and also some business services. So what our ID propose is to take the great concept and functional components of the CATS WG framework and then use OTN to complement a packet-based CATS and combine compute metrics with the optical layer metrics and establish an end-to-end hard isolation for the demanding service flows. And the service flow can be mapped into the optical containers such as the ODOK, FGOTN, etc. And the path selection may consider the deterministic path latency and the wavelength continuity constraints and the optical link performance and the compute resource state, etc. So for the key building blocks, they are all defined already in the draft IETF CAS framework, which is quite stable. And for like the service size, service instance, service contact instance. So the key point is to collaborate with the compute matrix with the optical layer matrix. Finally, we get a CATS aware OTN edge nodes. So when the service is identified by an CSID and the matrix, both from the network and the compute side, then distribute to the decision points, and we can choose the best instance and optimum path by the ingress OTN. And the traffic can be classified and mapped into the optical layer and finally delivered to the selected service instance. So what we would like from CCAMP, we need a deeper thinking on the deployment decision making based on some metrics like the computer side service status, GPU, compute load, memory availability, and from the optical side, the latency, wavelength, or time slot availability, and the link qualities, and also some operational questions like the deployment and OEM and interaction with ACTNs, and some security and confidential of the metrics. So next step, we believe that CATS is a valuable application for the CCAM technology for the deterministic and high bandwidth services. And we welcome the feedback and contributions. We request all the CCAM members to review and comment. So thank you. Any questions?
Yeah, I think actually this draft is very interesting, and the idea of this draft is similar to what we had discussed on CSO, cross-stratum optimization, introduced by Yang Li 10 years ago, right? So this draft, was trying to optimize, the resource between network and application,
Yeah.
including computing and storage resource. So after years of discussion, CSO draft, CSO framework became into ACTN, right? So this is the history of the CSO. So I mean, you can take a look at this draft for your reference. Maybe you can get some different things. Yeah.
Okay, thank you.
Thank you.
One comment from my side is the following. CATS already defines different metrics.
Yes.
So probably the ones for compute would not differ if we apply OTN or we apply other transport technology. So the focus here would be more on the particularities of OTM parameters and so, or, I mean, probably all the computer stuff should be essentially covered by CATS, and maybe here focus on the specific network side, right?
Yeah, in my opinion, I think for the optical layer matrix and how to combine it is within the CCAMP. Yeah, and we may deploy provide the use case to CATS. Okay.
Okay. Okay.
Major link in the queue.
Sorry, it's actually unrelated to this presentation. It's back to my presentation. I fixed that link, so if you could try that link again, it should give you access to the sheet. Okay, thank you.
Got it. Thank you.
Hello everyone, my name is Zhenhan from BOPT. Today I will present the updates to UNACO. Thanks to the great feedback from Daniele, Steven, and Adrian, we clarified the UNACO's scope and resource model. At the last meeting, Daniele asked why we focus on the optical networks. The answer is distributed AI workloads require the hard isolation, zero jitter, and deterministic latence. Only optic layers like OTN can guarantee this. That's why we believe this work belongs in the CCAMP. So we propose UNACO. It enables bidirectional awareness, resource abstraction, and joint orchestration. between optical transport networks and AI computing infrastructure. We identified three use cases where remote AI access is typical user-to-compute scenario. Distributed AI training and inference are massive compute-to-compute scenarios. Currently, the compute power schedulers and optical network controllers are isolated. For example, a computer power scheduler assigns a distributed job to 2 data centers with 3 GPUs, but it's completely blind to the congested optical links between them. This leads to massive compute efficiency loss. To solve these problems, we need joint orchestration. This brings us to 3 requirements. First, integrated control and management architecture. Second, unified abstraction and evaluation framework. Following the feedback from Steven, we have integrated the storage along with compute and optical states into the unified model. Third, scheduling algorithms for joint orchestration. These 3 requirements lead to a question raised by Adrian. How is the difference from cats? The table shows a clear boundary. Cats is about steering traffic over the existing paths. It's triggered by, when packets arrive at the ingress. UNACO is a lifecycle orchestrator. Before the first bit is ever sent, UNACO evaluates service intents, logs AI required compute resource, and provisions a brand new optical circuits. So CATS and UNACO are complementary. They address the different stage of the service life cycle. In CATS for OTN draft, optical channels are also provisioned. For massive AI workloads, only steer traffic over existing shared pipes are not enough. We need to control the optical layers to provision new physical or logical links on demand. Before the architecture, look at the service model. The computers specify their AI service intents, like training a large model. Then the service provider must translation these intents and orchestrate across 2 distinct domains, the network provider and the computing power provider. In the real world, there are usually different entities or at least different departments. So we must standardize the control interface to bridge them. UNACO's architecture builds perfectly on top of ACTN. The transport network controller is essentially an ACTN PNC, and the UTI interface is based on the ACTN MPI. Here is a critical difference. The unified orchestrator acts as an enhanced ACTN MDSC. We introduce a new domain, the computer power scheduler, connected via the new UCI interface. So instead of routing traffic, the UCOO takes the customer's intents and orchestrates both compute nodes and ACTN networks. Next steps, we will refine the architecture, clarify the relationship with ACTN, and detail these use cases. We also plan to update the draft name to better match our scope. We will design young date model for the UNACO interface. welcome more reviews and hope to seek WG adoption. Thank you very much. Any question?
Okay, Hao speaking. Not a question to you, but a kind of a common idea on this document and the previous one. We see some commonalities, and that is demonstrating the common interest on working on this kind of computational aware or whatever kind of trying to move the optical networks together towards the computing and the storage. So the chair mentioned the CSO work 10 years ago, and maybe we also have the auto ALTO work. And I would like to a little bit clarify saying that that's not ended as a ACTM, but we only started the network part of the CSO and auto through the ACTM. But the computation part is never done. And when they say CSO orchestration is just exactly the thing we need to coordinate among different perspectives. So I believe maybe we need to review the work again and see we are not starting from scratch, but we have already a good foundation to look at. And at this moment, people are encouraged to have this kind of gap analysis, especially towards CAS metrics, and then drive our technology forward to embrace those kind of trends. And I'm not the dog old enough, but maybe someone can correct me if they have more history. Thank you.
Thanks, Somian. And a comment from my side, which is I really liked the slide 7, the one comparing cats and this work, because this is exactly the best usage of our face-to-face time, because building that for a reader takes hours, reading the documents and understanding the comparison. So providing this type of work is something that is extremely useful. Good job, well done. No other questions? Next one.
Hello everyone, this is Yan Xia from China Unicom. I'm presenting the Young Data Model for FGOT network draft on behalf of our authors. The authors are from China Unicom, Huawei CICT, and FabHome. The main ideas about this work is describe the control interface requirements of FGOT and the 3 scenarios that require special consideration, and we define the young data model for FGOT. So the main changes from version 4 to version 6 is we add a new FGOT types young model to define the FGOT related types and have some update some changes to the FGOT topology model and have minor changes to the FGOT tunnel model. And we also updated the description of the multi-domain FGOT happiness resetting process and some editor updates. So what to be added in the FGOT topology or FGOT types model? We to identify the FG audio flex tunnel, we add identity FG audio flex based on the layer 1 types. So what changes bring to FGOT topology and FGOT tunnel model? For the topology model, we add one statement making the FGOT bandwidth under the max link bandwidth and unreserved bandwidth, making it applicable only when the audio type is the FG audio flex. To consistent with the changes done on the FGOT topology, the FGOT flex bandwidth under in the FGOTN tunnel model under the OTN bandwidth container with a when statement. This is the YAM model to describe the bandwidth of links which can support FGOTN. In this version, we define a new data type TS list in the topology model to describe the string pattern. The data type of the audio TS number has been changed from ULET 16 to TS list. For the max link bandwidth remains unchanged as the previous state, we add a one statement at this place. For the unreserved bandwidth, we add a FGOTN bandwidth leaf under the audio list to describe the FGOTN bandwidth before the server layer audio key is set up. And to better display and understand the FGOTN topology model, we give some example of link bandwidth at this slide. The bandwidth between node A to node B is 10 G, and we allocate to audio 0 for to support FGOTN. And so at step 1, no server audio key are set up on the link between node A and node B. The max link bandwidth and the FGOTN bandwidth under the max link bandwidth and unreserved bandwidth are 2500. At step 2, after one server layer audio 0 has been set up on the link between node A and node B to carry FGOTN traffic, the max link bandwidth remains unchanged. For the unreserved bandwidth, the FGOTN bandwidth under the audio list changed to 1250. And at this step, we need FGOTN list needs to update to report the server layer audio type and the server layer audio types TS, and the FGOTN bandwidth remains on this server layer audio key. And then we have uploaded the JSON code to our GitHub. Next step, we will give an example at step 3 once FGODU flex tunnel has set up. This is multi-domain for FGOTN Hattness resizing process. We update the resizing process scenarios in section 2.3 and update the Hattness resizing process in the appendix. One point we want to impress is that the reverse direction bandwidth resizing will be triggered automatically by the data plane. And the other point we want to impress is that only the source controller alone reports the bandwidth adjustment state to the coordinator after the adjustment is completed, regardless its success or failure. We think the open issue are not blocking for working group adoption and can be addressed as part of the working group development process. So we request the working group adoption. Next, we will continue the discussing the open issue on our GitHub, including more discussing on the FGOTN over audio CN, and we will update the JSON example for FGOTN topology and include the JSON example in an appendix, and we also have some additional editorial improvements to the test. We also have a biweekly meeting on Wednesday and welcome other people to join us, welcome to contact with us. Thanks. Any question?
Hello, Bingxue Wang from China Mobile again. And this draft is for the past computation extension requirements for the fine granularity transport network. So we have already presented this draft in PCE, and they need the requirements from the CCAMP. So we also present previously in CCAMP, and we have the comments to coordinate with GMPS and PCE. So and after that, we update the requirements draft and coordinate with the GMPS and PCE. We add some courses and update the ITU recommendations and add the FDM10 network layer structures, because we also do some FDM10 path computation extensions. So here in IETF 125, we also got some extensions, specific extensions for both FCOTN and FDM quality resource information reporting and path setup in the PCE working group. So we'll present this afternoon. And here's the requirement. So with the proposal of the new service demand transport technologies of the OTN and MTN are both moving towards the fine-grained hard slices. So in ITU has a series of the recommendations of the FDOTN and FDMTN. And this document is mainly focused on the requirements for the path computation and the control for the fine-grained transport network. So it's proposed to extend the PCE to meet the fine-grained transport requirements. First, so there are some vertical industries and dedicated line services have had higher requirements on the isolation, security, and the reliability, but with the smaller bandwidth. And fine-grained TDM technology can provide the flexible 10 megabits bandwidth for these hard slicing connections. So we can update the FDOTN and the FDMTN recommendations. They have a series for both support sub 1G clients overview and FG layer architecture, interface, adaptation, protection equipment, etc. So for the future massive fine-grained transport channel connections, how to effectively perform this end-to-end path computation and control will be an important topic. And for the reason and the requirement for why we need the path computation in fine-grained transport, there are mainly two reasons. First is the number of the fine-grained TDM channels is significantly increasing compared to the traditional connections, so based on the wavelength or ODOK or traditional MTN with a larger bandwidth. So like on one 5G MTN channel, it can support up to 480 FDMTN connections. And on one audio 2 channel can support up to 955 FDOTN connections. So within one device with a switching capability of several gigabits, can support fine-grained channel connections of tens of thousands or even more. And second, according to the service requirements, the fine-grained passes may change frequently and dynamically. And one fine-grained channel can carry and correspond to a certain CBR or Ethernet service rather than serving as a large optical channel. So when the services appear or its bandwidth changes, or the destination address changes, it will cause a change in fine-grained channels. So as a conclusion, compared to the traditional optical networks, the fine-grained transport networks require more quantity, faster, and more flexible path setup and removing capabilities. And we think that centralized computing model of PCE architecture is solution for the fine-grained transport network also. The use cases, including like fine-grained path setup, resource management, update removal, and some service awareness and mapping at the P node. And the requirements of PCE extensions mainly include PCE PLS to enable the collecting of the link states and the resourcing and the path calculation, request and reply message to include fine-grained channel attributes. These are two parts. So next step, we believe that path computation of the fine-grained transport is required now. So on this draft, is mainly proposed to the requirements to extend the PCE for the fine-grained transport. And the specific extension will part of the PCE and will apply in the future. So any comments are welcome. So thank you.
Fatai speaking. So one comment. So a few minutes ago, before this session, I talked to you to confirm that this draft covers both FG OTN and FG MTN.
Yes.
But you use FG transport in the title and abstract of this draft. Actually, ITOT only defines FG OTN and FG MTN. They don't define FG transport. This will confuse people. So. Yeah, I think you can describe FGOTN and FGMTN explicitly.
Okay.
Yeah, thank you.
And a comment also from my side. So I missed your presentation in PCE. Just to clarify. So this draft is meant to be in PCE because it's PCEP requirements, right?
Yes.
So it's presented here for information and to get feedback. So you're not planning to have it moving forward in CCAMP, or?
I plan to move it forward to CCAMP because PCE is that the requirements belongs to CCAMP, and they are just
typically PCEP requirements are defined in PCEP. I don't know. We can talk to the PCEP PCE chairs and find an agreement.
They are just also
to get confirmation from CCAMP about the requirements of the PCEP extension.
Okay.
Yeah.
So they bring this draft to CCAMP.
But ask for confirmation of requirements doesn't mean that the draft belongs in CCAMP. But I mean, that's an offline discussion we can have, no problem. Thank you.
I agree. I think this draft should go both the working groups. Right.
Can you see my slides?
Yeah.
Yes, just a second. We are giving you the control.
Sugan, you have the control now.
Okay. So let me control my slide.
Yes.
Okay, great. So my name is Sugang Xu. It's my pleasure to present our draft. Here is the draft focusing on the WSON related work for in the landscape of the WSON. It's related to the information sharing of optical impairments in a multi-domain scenario. Large-scale multi-domain WSON networks support end-to-end optical paths, and with along the optical path, the optical impairments accumulates across administrative domains, including OSNR, GSNR degradation, nonlinear noise, dispersion, and so on. And these impairments can significantly reduce the quality of the signal, eventually lead to the service degradation or failure of the receiver. Well, existing RFCs and internet drafts support impairment-aware path computation, provisioning, and validation. But in the lifecycle of the LED path, we have also the impairment monitoring and the restoration and so on. Those issues are still remain challenging, I think. So we raise this question in our CCAMP for further discussion. Since the data is critical for any design of analysis, so we first see we need cross-domain performance data sharing capability within WSON to offer measurement, estimation information to facilitate cross-domain monitoring and analysis. Here is a slide to further detail the requirements for cross-domain performance data sharing. Within the diagram, we can see when signal degradation, here, can I see my mouse? Well, anyway, when signal degradation along the multi-domain optical path, the receiver at the right-hand side may detect a drop in signal quality, such as OSNR, Q factor, and something else. If the cumulative degradation exceeds the thresholds at the receiver, the service may fail. So at that point, operator must identify which domain contributes most, but the information collected at the receiver might be insufficient. So we can see we need a cross-domain performance data sharing to offer more data for analysis, such as degradation analysis and photo localization. And we identified two primary use cases which facilitate such kind of a cross-domain performance data sharing. The first use case is faster restoration. When signal degradation fails, at the right-hand side, the receiver will detect the failure and trigger end-to-end restoration. And that'd be fine, and at least we have such kind of approach, but may have a higher operational cost because we need to involve lots of process in this restoration. But on the other hand, as an improvement, if the affected domain, for example, domain B can be identified, the restoration can be performed locally and quickly, for example, between the border nodes within that domain. The second use case is SLA responsibility attribution. Say, if the performance degradation affect the entire end-to-end path service, in that case, the operator need to know who have the most responsibility for this field. In that case, if we have the data collected by cross-domain performance data sharing, the performance can be analyzed together to identify which domain contribute most. For example, domain B will have the most responsibility for this. In that sense, the use case show that the benefit, say, the collaborative analysts can provide the quantitative and objective evidence of degradation contribution from different domains, helping to clarify the responsibility and reduce disputes. However, we need to consider more constraints within this problem. So here we identify two key constraints. The first one is limited observability at boundary nodes depending on the architecture design. For example, within the domain B, if no monitor device is placed at the boundaries, So we cannot use the telemetry information directly from boundary, but we need the performance monitoring and telemetry and estimation capabilities within that domain, which might be limited in terms of both measurement accuracy and temporal resolution due to the higher computational complexity and load. So that's very important to consider such kind of constraint. Another constraint is confidentiality. In addition to the internal topology, the detailed physical layer information such as metric parameters of optical devices and cannot be shared. So we have to consider the detailed cross-domain sharing must rely on abstraction and aggregation as a generic guidance. Oh, here, let me review my talk. Our motivation is to raise a discussion in CCAMP. So because we think that it is very important to find the fundamental assumption on constraints. Well, we didn't find any documents already on this issue, so we need to create the foundation on constraint firstly. We expect feedback, guidance, and collaboration in CCAMP. But the first thing for us is, please let me seek the kind of opinions from our CCAMPers, whether such kind of work is interested or beneficial to be discussed in CCAMP. That's all. Thank you.
Hi, Italo Busi Huawei. I have a question for clarification and depending on the answer, a comment. Domain A,
Yes.
B, and C are three different vendors or are the same vendor?
They might be different or same vendors.
Or same vendor. So why do you split into three domains?
Actually, they are three operators. They are running different domains. Actually, domain A, B, C will be owned by different operators.
So
it's kind of a multiple administrative domains scenario.
It's a multi-carrier scenario at WDM layer.
Yes.
Okay. Okay. Never heard about that. Okay. Good to know.
Thank you so much.
Thank you. Iowa from FutureWay. So yeah, I think probably the same thought as Italo mentioned. So basically, you're saying those belongs to three operators, and with no like common orchestrator or multi-domain orchestrator on the top, right? That was different from what we have dealt with, because in the current ACTN framework, we have a multi-domain MDSC on the top for multi-domain coordination. So now you're more talking about the east-west sort of communication between different domains, if I understand.
Yes. Yes.
Okay.
So I'm not sure whether our focus in CCAMP will be extended or not. But anyway, I think it's quite a practical issue when WSON should be pushed to the market. That'd be a problem for interconnection among different operators.
Yeah, I would say this to me it's an interesting scenario, but also the fact that you are doing cross domain at the WDM layer, that's also unique. Probably need to think about it.
Really good to have input from operators, because it's whether operators are peering at the WDM layer and at the ASON. It's new to me, so that's why I would like to hear feedback from operator about this type of deployment scenario. But thank you.
Thank you so much for your comments. Actually, we expect any feedback, comments, guidance, and collaboration within CCAMP.
Roberto, quick comment?
Hi, hello.
Hello, Robert.
Hi, Roberto. speaking. I think this scenario is probably coming from the ION Global Forum. That is one of the probably the unique place where I heard about the peering between operator at TWDM layer, right?
Yes. Actually,
Okay.
here is a discussion within the ION community, but how to say, we are for sure we are doing the research work. Is
Okay.
a little bit far from the current step, but anyway, I think in the future we must face to such kind of a problem.
Anyway, it's an interesting scenario that it's good to look at. Thank you.
Thank you so much.
Probably it also depends on how you define a domain. That's yeah, but it's the same vendor. I understood. So maybe
No,
a different
actually,
concept of domain.
sorry, Daniel.
No, I was saying that this is an unusual scenario, but probably the word domain is used in a different way than we are used to, in the sense that when we speak about the different domains, we speak about the different controllers, different vendors, different everything. Here, there are a lot of things in common. So I don't know, maybe it's a particular type of domain. That's what's creating a little bit of confusion. Okay.
And so thank you so much for your comments, and let me contact with you for more seeking your kind of opinions.
Thanks to you. Thanks a lot.
Thank you so much.
So we have seen a lot of requests for working group adoptions. We are sorry that we didn't have time to do polling because we already have a super packed agenda, and as usual, we are a few minutes late. We shared yesterday the list of priorities that we identified, the top 3, top 4 for working group adoption and working group last call. So we will continue with that, and we'll add the new drafts to the backlog. Thank you. Thanks a lot. That's it. Have a good rest of the week, and goodbye.
Bye-bye.